Hello, today's video is going to be on how to write your quadratic equation in intercept form. Now, intercept form, if you remember, what intercept form does is it shows you the x-intercepts in your graph. And so what we want to do is, given our x-intercept form, we want to find out what those intercepts are. And to do that, we take each of our individual pieces, our individual factors, we set them equal to 0, and we solve. So we add this 1 over, 5x equals 1, we divide by 5, so we get x is 1/5. Now if you remember, anytime we have an x-intercept or a y-intercept, when we have an x-intercept, our y is equal to 0, we always list our answer in coordinate form. So the x-intercept isn't 1/5, it's 1/5, comma 0. And then our next one, easier, x minus 2 is equal to 0. We add the 2 over, we get x equals 2. So our second x-intercept is at 2, 0. So this graph, our quadratic, has those two x-intercepts of 2, 0 and 1/5, 0. Now we were lucky that equation was already in intercept form, and what intercept form is valuable for is that it gives us the x-intercepts of our graph. Now what if our equation's not in intercept form, but we want to make it into intercept form? An easy way to write an equation from standard form to intercept form, all we have to do is factor. So we have all of those different ways in which we can factor, so it depends on what kind of equation you start with. So let's go ahead and get started. We have an equation, so it's not just x squared minus 4x plus 4, it's y equals x squared minus 4x plus 4. You go through your checklist of all the different ways that you can factor. We have 3 terms here. Our a value is 1, so this is going to be regular factoring. We're looking for 2 numbers that multiply the outside and add to the middle. As we set up those parentheses, that's x and x. If I'm multiplying to a -4 and adding to a negative, that means that they're both negative, and in this case they're both -2. So a quadratic, our parabola, in this case, here's our equation, I only have one piece. So when I set this equal to 0, I only have one x-intercept, and that's going to be at 2, 0. And this occurs when your vertex is the x-intercept. So only the vertex of your graph is touching. So here's our equation and intercept. Whoops, I lied. Here is my equation in intercept form, and then there is my one x-intercept. It's actually going to count as a double or a bounced root, which we will get into more later on. And number 3, I only have 2 terms. And this is the one that throws people off a little bit because it's not the difference of 2 squares, because you forget about the first step of factoring. And the first step of factoring is GCF. And I look at those 2 pieces, I can pull out a 3x. 6 divided by 3 is 2, 1x left. 3 divided by 3 took out that only x. So there's my equation in intercept form. We still set each piece equal to 0. So 3x equals 0, x equals 0. So I have one x-intercept at 0, 0. And then we have 2x minus 1 equals 0. We add that 1 over, we divide by 2, giving us x equals 1/2. So our second x-intercept is at 1/2, 0. Number 4, it looks like it's going to be Batman, but don't worry, it's not, because again, our first step is GCF. When I pull out that GCF, I'm left with a regular factoring. And remember, regular factoring, we're looking for 2 numbers that multiply to the outside and add to the middle. So here, I'm multiplying to a positive and adding to a negative. That means that both of my pieces have to be negative, And I need two numbers that multiply to 8, but also add to a -6, -4, -2. So here's my equation in intercept form. We set each piece equal to 0. 3 equals 0, no variable, no solution. X minus 4 equals 0, so x is 4. X minus 2 equals 0, x is equal to 2. So we have our x-intercepts here are at 4, 0 and at 2, 0. All right, so just a review on how factoring can get us our equation in intercept form. And once we have our equation in intercept form, we can find those x-intercepts. All right, and now a little bit of a different twist on how to write the equation in intercept form. So factoring is what we do if the equation is in standard form. But we can do it with other given information. So we're going to write the equation in intercept form given some information. So first, we are given these x-intercepts. And second, we are given a random point. Remember, a random point, this is my x-coordinate, this is my y-coordinate. So we have our reminder here, what intercept form is. So that's what we're going to start with. Y equals a, x minus p, x minus q. So I'm given that my p is 0, my q is -6. So if I'm subtracting a negative, that's a positive. Remember, anything in the parentheses is the opposite. Now the point, what the point does is it gives us that x and y coordinate. So now my y from my point is a -54. My x is 9. If you notice, our equation has x's in 2 spots, so I have to fill in the 9 in both spots that there is the x. So now the only information that we don't know is the a value. So from the givens, I have everything I need. I just need to find out what is the a value. Remember, the a value tells us whether it's been reflected, if it has a vertical stretch or vertical shrink. So we're going to go ahead and solve this. A -54 is equal to a. 9 minus 0, well, that's 9. 9 plus 6, that's 15. 9 times 15 is going to give us 135. So this becomes 135a. We normally put the coefficient in front of the variable, and then we divide by 135 so that we can get the a by itself. So I have a -54 divided by 135. When you divide and math frac in your calculator, you get that a is a -2/5. Remember, that was the piece of information we were missing. We want the equation in intercept form. Remember, intercept form should have the intercepts. So we're going to be able to see the intercepts in the equation. Your equation should have the x's and the y's. So this becomes y is equal to your a value, which is a -2/5. Now this was x minus 0, so you can keep that as x minus 0, or you can just write x and then x plus 6. So remember, you can write it like this, or like this. Either one of those would be correct. So in intercept form, you have the x-intercepts and the a value. Make sure that you don't keep that 0.9 -54 in there, because remember, that's just one random instance on your graph. All right, so for number 6, we're actually going to do this the same way we did number 5. The only difference is in number 5, I told you what the information was, and in number 6, I showed you what the information was. So here, I'm showing you that your x-intercepts are at a -1, 0 and at 3, 0. And then I'm showing you that you have a random point at -2, -6. And maybe it's not a random point. Maybe I give you the y-intercept. It really honestly doesn't matter. You just need your intercepts and a point. It doesn't matter what point it's going to be. So what I want you to do now, again, is I want you to press pause, and I want you to use that information to follow what we did at number 5 and write your equation. When you're all set, go ahead and push play and see how you did. Okay, let's see how it went. So again, we start off with the general form. The x-intercept of a -1, when I put that into my equation, it becomes a +1. The x-intercept of a +3 shows as a -3, opposite on the inside. And then I took that point, I plugged the -6 in for the y, and I plugged the -2 in for each of the x's. So the only thing that I have left to solve for is my a value. I simplified. -2 and 1 is a -1, -2, -3, -5. When I multiply a -1 and a -5, I get a +5. We divide to find our a value. In your final equation, remember, you're showing the a value and the x-intercepts. Hopefully you did not forget and you did not plug in those x and y's from that random point. All right, hopefully you did well on that one. We are all finished for intercept form.